Hey, there you go. So welcome Solar Tuesday. Anybody have anything? I know Bob and I were chatting before this got started, but anybody have any topics they want to bring up before we get into some of the latest news here? Okay, if you do, just don't fail to interrupt. I was looking through some of the news and I found we touched on some of the prices. I know Bob, you were mentioning about 250 for residential solar. Unless you live in Illinois, then it's like $42 or something. So, but I saw some 2020 numbers, and the residential was 271, which is in line with what we were talking about before. These are national averages. But I found it interesting. Commercial installs are at $1.72. So that's quite an economy of scale there. And then utility scale on average are 94 cents a watt at the very large scale. And of course, the utility scale increasingly are using thin film panels, which is kind of interesting as opposed to silicon-based panels. And with that in mind, I saw one of the other new things was that First Solar is opening a third manufacturing facility here in Ohio. They're anticipating having 6 gigawatts of manufacturing capacity. They are the largest thin film manufacturer in the world. And they've decided to locate most of their US-based capacity here in the northwestern Ohio region, up around Toledo. I know there was another one, I forget where it was located, but there are 3 plants now that they're opening up there, employing quite a number of people. I think this new one they said would hire 500 people, which is interesting. I don't know if that's just through the initial construction or ongoing. Dave, you had a comment on that?
That's ongoing. That's employment to operate the thing. Yeah, they're huge. Their U.S. production is really only about half of what they're importing as much as they're making. And
yeah, I saw that they had facilities in Malaysia and Taiwan, I think.
And are they making the panels or the associated stuff, or what exactly?
They're vertically integrated. They do everything from raw materials to finished panels, actually to constructing utility scale plants on a turnkey basis.
Okay, so they do all the stuff like the the superstructure, not the superstructure, but the what am I talking about? The poles, whatever you want to call it. It's all freestanding. So the
yeah. When you see fields of them, yeah.
Yeah. Okay.
Huh. Yeah, big fields of them. That's utility scale.
Okay.
Pretty often, and I think they're the biggest utility scale developer in the country, and they were the first. Also, they basically they made the industry.
Mm-hmm. And they're not a utility themselves. They just sell to utilities. They don't do anything for their own account.
I believe they have been. They're changing their business model, but they have been owner operators.
Okay. Okay.
Oh, so they would basically have a feed-in tariff of some sort selling to the utilities, but own and operate the utility scale fields.
I don't know how they do it, but I'm guessing that they must have power purchase agreements with utilities before they build.
Yeah, because a lot of these now, like Amazon, we talked about the other week, was doing some power purchase agreements for in a 3-state area, I think Ohio, Illinois, and Pennsylvania, if my memory serves. So they would, I guess, contract with someone like a First Solar for the feed-in. So I think, we're seeing the electric market change so dramatically that my guess is in, a decade, it's not going to look anything like what it looks like today. I'm really still waiting for a company like Apple to begin offering consumer level virtual utility services, because that's really where everything changes. Pretty much just like the telecommunications industry changed when you started going through deregulation, Ma Bell owned and operated all of the lines, all of the infrastructure. And there was a famous court case where Judge Green stepped in and said, hey, you've got to lease out a portion of this facility to, I think it was MCI at the time. And once that happened, then multiple companies could lease space on the infrastructure and sell services. And once that happens on a wide scale, Apple has already, purchased access to the grid so they could sell their production directly to consumers. So at that point, then it's just a matter of anyone who feeds into the grid can market through a blockchain type system to other consumers. It just, power onto the grid, power off of the grid, and then it's all just accounting. So now we've essentially created virtual utilities, and then all bets are off. Yeah.
I was going to ask Jay, do you think that this is just an opinion, I guess, is this going to increase or decrease the stability of the grid if we have a lot of these extra providers? It's always good to have more power, yes, but there's, just having more doesn't always make it more stable.
Right. I would say probably both. Having players who are using the infrastructure who have no skin in the game in maintaining it is never a good thing. But already that's the case. And already the grid is sort of hanging on by a thread. So I don't know how much worse we can make it, but
that's not a heartwarming feeling.
I know. It's sort of like politics. Can we make it any worse? No, probably not. So,
Okay.
Yeah, Bob.
Jay, I'm pretty slow on drawing my pen out to write down information. How much was the commercial dollar? What?
Yeah, $1.72.
And the name of that company, I know the name, but I can't.
Yeah, it's First Solar. First Solar is the company that's manufacturing all of the panels in Ohio.
I've been up on their website a couple of times. I just don't remember the name.
Yeah, it's interesting because, of course, we talk a lot about all of the panel production being offshored to China. And of course, that's true. It's kind of interesting because solar panel manufacturing is pretty automated. So it hasn't occurred because of low wages. It's occurred because of a governmental focus on trying to capture an industry. So they specifically targeted solar and, okay, we're going to become the leader and dominant player. So I'm sure there were a lot of subsidizing through the national system. Then, of course, they offshored a bunch of their production in response to the tariffs that the Trump administration put in, where they said, we're not, we're going to charge this on Chinese panels. So the Chinese manufacturers just manufactured them in Singapore or Bangladesh or Malaysia or Indonesia or wherever they chose to. So they get around those kind of tariffs. So it's an interesting, but we're seeing some of it return to the U.S. We'll see. I don't know. I don't know if that's good, bad, or indifferent.
I know I bought some printed circuit boards from China, and I had to pay both American and Chinese upcharges.
Yeah,
it was about 20%.
I think what we're seeing, at least in the short term, I was talking to a friend of mine who's involved in telecom sales, and he said because of the supply chain disruption in the post-COVID world, they're just seeing 3-4 month delays in shipping. I think basically what happened is all of these businesses, because of uncertainty, they ate through their inventory. They didn't place advance orders. And then when it came back sort of with a vengeance. And they're all being caught, flat-footed trying to get things through the pipeline. So I wouldn't count what we're seeing in the next couple of months as anything that's indicative of where we're at. Although speaking of in the last couple of months, the numbers for solar in the US, Q1 for 2021 was, I was looking at the wrong number here. The first 3 months, 46% more in Q1 over a year ago. And remember, 2020 was a record year for solar. So we're seeing that. In fact, they said that there were 5 gigawatts installed in the first 3 months. Basically, solar installed in the US has doubled in the last 3.5 years. So we're at about 100 gigawatts. So 3.5 years, we're at about 50 gigawatts. So it's going great guns.
Yeah,
And
Jay,
yeah,
I think this is going to be like, remember you brought up the telecoms earlier. Do you remember when Global, I forget what it was called, Global somebody and MCI, everything was overbuilt, and all of a sudden, telecommunications dropped in price, and then they all went bankrupt.
well,
I mean,
it was a little more, it's funny because I was actually running a trade association for telecom at that time. And it all happened while we were at a conference. Like everybody showed up for a trade show and they were all setting up their booths. And before the week was out, about 50% of the people at this trade show were unemployed. And they mostly just left their trade booth there and said, screw it, I'm out of here. So it was really chaotic. But part of the problem there was really sort of inherent in the Bell system. All of these guys who ran and managed in the Bell system thought they were administrative geniuses because they couldn't not make a profit. It was a regulated system, and no matter how bad they screwed up, they were still making a profit. And everything that they had to do was prescribed to them through the Bell practices. So they didn't have to make any decisions, and any decisions they did make had no consequences. So then when they began to compete in the real world, they did amazingly stupid stuff. And so, any idea they sketched out on a mattress or on a napkin seemed to have, financing available. The internet bubble was going on, and these guys were doing dumb stuff. I remember Lucent, the guys at Lucent would go out and sell like $1 million PBX system on credit to an internet startup company and book the $1 million sale. And there was no way these 2 guys and a Cocker Spaniel were ever going to pay for this $1 million PBX. And then it sort of all came due at once. And so it was just really kind of a bubble on top of a bubble. Okay. I don't know that solar's the same way, but I am concerned because we are seeing such dramatic growth, and there's got to be a limit to how many utility scale PV systems the world needs, especially once people start putting it on their houses. They're building, the utilities are looking at it like we've got all of these centralized power plants that need to be replaced. Right. And we can replace them cheaply with utility scale systems. But they're not taking into account the fact that their customer base is also replacing their retail purchases with self-consumed energy. So you say, okay, am I expanding my infrastructure at the same time that I've got a declining customer base?
There's a lot of room for everyone.
Pardon, Dave?
We need to multiply what we have by more than 50 times. I mean, there's plenty of room for everyone.
I think so. I think, and plus when you start adding in the transportation industry going electric, now we start to see quite a lot more demand being thrown into the same system. So I think
heating and hot water.
Yeah, we're definitely moving. We've got a lot of slack in this before we've hit saturation, but I think it's something we can't become reliant on 50% growth rates every year, to sustain an industry. That, first off, just
only has
naturally,
to-
that's going to decline.
Yeah.
Well, if we're hoping to have a 50% carbon neutral grid by 2030, we may actually have to be looking at expansion at those rates.
I think we
Yeah.
can keep hoping because that's, that's.
Well,
I think-
it's interesting. I know some of those projections, and when I did some research on it, like everything that you hear, it's a little bit misleading. Because most of when they say that they're reducing by these huge quantities, they usually are backdating to 2008 as the starting point, and about half of those have already been accomplished. So they're building in, they're sort of front end loading some of those numbers, but it's still a worthy goal. And it's that kind of thing, shoot for the stars and land on the moon. We'll see where we end up, but we've got to have aggressive goals.
Does
I
Does anybody
think,
know?
Yeah.
Does anybody know what the electric vehicle adds to a consumer's household
as a
electrical
matter
consumption?
as a matter of fact, I was just looking at that. It adds on average about 10 kW a day, 10 kilowatt hours a day. That's if somebody drives the normal 35 miles a day, 38 miles, something like that. Because I was updating a textbook and I had to kind of, so if you're doing some like load estimates for a building, I think 10 kWh per day per vehicle is a pretty good number to throw out there, as
Well,
close as you're going to get.
that's exactly what I was wondering, because you talk about get the electric car. Well, most people have two vehicles, so in the future there's two cars. They're all consuming, and now you need even more in that panel
Yeah,
to be able to feed those two cars every night.
We're looking at 2.5, at least 2.5 times existing system to accommodate all the additional uses we want to load onto the system.
yeah. And if we can factor in the idea of microgrids, the idea of using your electric vehicle as a battery backup storage for your facility, whether it's a commercial or residential facility, all of these things are going to reduce some of the load demand from the greater grid, so that we could perhaps increase our load overall by a factor of 2, without having to do substantial infrastructure growth to the grid structure, because we're consuming and producing a lot of the power where it's being consumed. So distributed systems are going to be a bit of a salvation to the grid. Although I think Don brings up the point that a lot of people playing in this playground without cleaning up their own mess or maintaining the infrastructure is going to be a big issue. So I'm not quite sure how that's going to work out. I can see it, like I'm sitting here on a college campus. I can see the campus being okay because they're going to own and maintain their own infrastructure, and eventually they'll have their own generation facility at some point, and then they'll use the grid as like they're a node on the internet. If I need more power, I draw from it. If I've got excess power, I'll send to it. But they'll be relatively self-contained through a microgrid system. But I don't know how you deal with on a municipal level, because our government doesn't seem to be very good at coordinating pretty much anything.
We need
So-
much better coordinating institutions. And
Yeah.
we're going to have to make that happen at a much more integrated level than we have.
Yeah.
Jay, do you think universities will do that well? I mean, you've been to UD, you've been to the NCR campus. Those sun tracking solar panels stopped about 2 years ago.
Yeah.
And they have not moved since.
Yeah, I
mean-
think they'll do it relatively well. I mean, we got to cut them a little bit of slack because they're usually on the bleeding edge of this technology. And so they do it first, and they probably don't do it very well when it's first done. And then they lose their grant or whatever, and they don't have any money to maintain it. But if it's part of their total infrastructure, you know, they'll do it pretty well, better than a city anyway, because there's like one entity in charge, you know, the president or the board usually is pretty focused on keeping the wheels of the institution moving forward.
Somebody's actually accountable.
Yeah, and it doesn't change every 2 years or whatever. So,
Yeah.
you know, I think that's something that's hopeful there. And of course, the more microgrids we have interconnected, just like the internet, the more resilient the system is as a whole. What we'll probably see is then a lack of the need of the high-speed transport lines, you know, the way that we need them today. I'm afraid that the utility system is still viewing renewables under the old centralized distribution mechanism through that lens. And I think that's not necessarily how things will play out.
And that's not necessarily how the industry is looking at it either. I think take a look at the Eaton Corporation website. They do a lot of, they're based in Cleveland. Well, they were based in Cleveland. They're based in Ireland now. But they produce a lot of equipment for the utility industry. And they have, their concept is very integrated and very widely distributed system emerging, and that they are dedicated to being the suppliers to.
Okay,
It's worth looking at their website.
I hope
Are you
that
kind
works.
of assuming? Go ahead.
No,
I was gonna say,
go-
you're kind of assuming a big improvement in the storage, because again, you still got the base load issue.
yeah.
You'd have to have distributed, you know, a big power plant to do that. But do you think there'll be enough improvements in the storage to make it really distributed like that?
Well, and yeah, and that's one of the things that we're talking. In fact, I had said today we would focus a little bit on battery and storage, but I did a little bit of research there. When we talked about the growth of solar in the first quarter, the growth of storage on the grid increased 252% in the first quarter versus 2020. Yeah, 252%. And part of the motivation for that, or the supercharging, is they just recently passed that investment tax credit for standalone storage. Before it had to be integrated with PV or renewable systems. Now utilities can put in just a storage facility, isolate it all by itself, and still get the investment tax credit. So that's going to be a big driver. But then, of course, the reduction in cost of lithium ion. In 2010, lithium ion cost $1,100 a kilowatt hour for storage. By 2020, it was down to $137. So almost a factor of 10.
Yeah.
And by 2023, they anticipated it'll be around $100 a kilowatt hour. And by 2030, down to about $58 a kilowatt hour. So who knows where the future goes, but definitely the trend is cheaper, cheaper, cheaper. And what that really tells me is, if we're looking at today, let's say when the first electric vehicles were deemed to be economical, it was about $150 a kilowatt hour for the batteries. And the battery cost makes up about 50% of the cost of the vehicle. If by 2030, that's down to $50 or $58 in that range, that means the cost of a typical vehicle will have been reduced, what, by 1/6, you know, if it's, or more than that, 4/6, right? If it's two-thirds reduction of half, so 2/6, 1/3. So the cost of the vehicle will be 1/3 cheaper.
Yeah.
Which,
When they pass it on.
it's dramatic. Well, yeah, who knows? No, we'll all be driving Indian-made vehicles by 2030, you know, and they'll be fully electric. And, you know, that's something hopefully the car manufacturers will adapt and make their vehicles cheap enough. But really, once we have cheap, affordable, ubiquitous electric vehicles that are all designed to interact as a battery backup storage to the grid, and I mean, then your battery capacity. In fact, I saw their I'm going to go with memory, but anyway, it was like they're anticipating in a short period of time, all of the electric vehicles in the United States will have enough backup capacity to provide 1 hour of energy backup storage for half of all of the energy consumed in the country. So essentially, we would have, through electric vehicles, a half hour of UPS storage supply if they were all connected, which
So,
is not enough, but it's a lot.
so batteries and electric cars and all this, I know lithium is the focus, and I have to confess total ignorance because I've done zero research on this, but I've heard over and over people claim that lithium can't be recycled, and that even if it could, there's no interest in recycling lithium batteries. So any truth to any of those
There are
statements?
lithium recycling facilities under construction in the United States right now.
Yeah, there is some truth in that historically the cost of recycling lithium has been greater than the cost of making a battery new with new
Raw
lithium.
materials. Yeah.
But that's been the case with almost every material in its early stages. So as we have more and more of this capacity, clearly that's going to become a thing. The damage, I think, with lithium in the short term is environmental in the mining of the lithium. That causes severe environmental issues in places like Bolivia, Argentina, Chile. So that's just part of the extraction economy where they go in with no regard for the local environment. And I suspect lithium will be a bridge technology to something else, whatever that something else is, whether it's saltwater batteries or whatever, but whatever it is, it's got to be lightweight, and probably non-liquid, just like lithium, high energy density.
There are
So
non-toxic flow batteries coming out now that are based on very common materials. There's a whole ways to do this. The main way now, it used to be like 98%. Now it's about 95% of all the storage in the United States is called pumped hydro.
yeah,
It's,
yeah, and we're seeing on the utility scale, there are different solutions. Like the flow batteries that you're talking about is a good solution, for grid storage, because basically the electronics are all stable, and then you just increase the size of the electrolyte tanks and you can increase your storage capacity to virtually unlimited. But that's not necessarily a solution for an electric vehicle. And you've got pumped hydro, which works where there's usually in conjunction with
about, if we're looking at the entire storage needs of the entire system that we're considering right now, then lithium may be a significant but not a huge part of it.
Yeah, well, and we're talking with issues, especially California is leading the way on this, where they've got a lot of excess capacity of renewables already during certain hours of the day. So they've got to curtail some of the renewable generation, whether that's solar or wind. And that's not an ideal situation. When you have energy available, you would like to see it being utilized. So obviously storage is the solution when you have that situation. So you can have some relatively inefficient storage mechanisms that are taking advantage of curtailed energy that are still economic. So
that's starting to happen. That's the story about hydrogen, which is taking off right now.
Yeah, but even things like compressed air, gravity storage, pumped hydro, all of those are ways of just taking essentially kinetic energy. You raise something to a height, whether it's water or bricks, and then you drop it to generate power later, or compressed air. So there's huge numbers of options out there. Lithium just happens to be flavor of the day.
Power losses and an inefficiency in the energy conversions involved in storage mean that And because we would need a large amount of energy storage, mean that the overall size of the system has to be increased in a fairly considerable amount. Not doubling, but it needs to be increased substantially to accommodate that inefficiency of in regards to storage.
But I'll make my my prediction, however, and I'll probably never be proved wrong, I'm assuming, that hydrogen will never become the solution. There will always be a better solution than hydrogen. And
Possibly, yeah. I mean, it's certainly coming into its own in terms of for difficult to decarbonize sectors like steel making.
yeah, usually that's through political pressure, though, as opposed to that it's the best solution.
Well, yeah, yeah, right. To come up with optimum technological choices, we can't rely on the money system.
Yeah. Yep. So let's see if I've got anything else on batteries.
I have a question, Jay.
Yeah, Bob.
Okay.
Uh-huh.
How does hydroelectric work without water?
Probably very poorly. So
Have you been to Hoover Dam lately?
I saw some pictures of that.
Hello.
Las Vegas is in trouble, huh? Well, that goes
Not
without
more
saying.
than that. But we're in
Yeah.
a drought. We're in
Yeah.
a big drought in most of America.
Yeah, that's going to be very problematic because a lot of the country relies on hydro. Tennessee Valley Authority, the Northwest US. Not sure if Oregon and Washington are in any kind of drought situation, but yeah, that's something that I don't know what the solution is other than wind and solar. So
Jay, I have two questions. One's for batteries. I saw a couple weeks ago that there was another company out in California trying to make a push for the replaceable battery approach for vehicles. I was wondering if anything is coming up on that. And the second was back to your original point. Was it Cleveland that first solar it in? Or Toledo, you said, that they were putting in a plant?
yeah, Toledo area.
In Toledo? I'm just curious, if they're making the panels up there, is that something you can actually go up and look at? You know, do they have a tour of their plant or?
Why don't you, yeah, go online and find out. They very well might have. They're pretty proud of their technology. They are, what they're building, what they'll have when they're finished building this third section. They just recently finished doubling the size of the plant. Now they're now approximately doubling the size again. And they will have the largest PV production center outside of China.
Okay, that would be something to drive, you know, might be worth a drive to Toledo. Not much else is, but that would be.
You can watch a Mud Hens game while you're up there, right?
You could, that would be the other option.
I'm looking at their plant from the aerial view here, and it's just covered in panels, as you would hope. And then they've got a warehouse up the road a little bit, but there's more panels. I don't know. There's a big ground-based system right there by their plant as well. So
Okay.
looks like they've got a lot of solar to look at around right where they're sitting.
Yeah, well, I'd be interested in seeing them actually, the production piece of it. That'd be, if they would, you know, if there's an option. Okay, I'll check it out. Thank you.
Yep. Well, I just always use the analogy, and maybe it's because I was in the telecom industry when the industry was transitioning from the Bell system to sort of the modern internet type based system that we see today. And those were exciting times, and it was dramatic changes. I mean, the industry pre-transition almost looks nothing like the industry of today. But it doesn't mean that there weren't a lot of problems along the way or that everything that resulted was good. So I think we're in that same situation with the electrical grid, where in 20 years, you know, all of us old gray-headed people are going to get together, you know, gumming our food and talking about the days back when there were centralized utilities. And it will be a completely different world with, you know, the integration of distributed and the integration of EVs and the Internet of Things going over wirelessly and over power lines and everything. interoperable and we'll probably lament the good old days when, you know, every appliance was tracking what we were doing and what we were saying and what we were thinking, you know, or whatever. But we're in for a ride because this industry, this whole world is really going to become the solar age. I mean, we're kind of entering into this for
Right.
the next couple of decades. I think every industry, just like when we transition to using computers, you know, every single industry is now 100% computer based and 100% computer dependent. And every industry in the world will be 100% solar based and 100% solar dependent. And what that means, who knows? Who knows how that's going to look? But it's going to
So-
happen.
So I'm seeing at least one article every week about net metering trying to be legislated or another what in some way or another limited or ultimately killed all over the United States. I mean, it's just where is it this week? I mean, with you talking about Eaton trying to serve this future grid, where is net metering going to land in all this? Obviously, no one has an answer, but I'm just curious from what you see and what you understand.
Well, I can tell you my estimation of what's going to happen, and I'm sure others will disagree or have their own insights, but it always reminds me of the Gandhi quote, you know, first they ignore you, then they ridicule you, then they attack you, and then you win. You know, it's for a long time it was ignored, then it was a joke, and now solar is under attack. The legislation that allows for you to send your power back was inconsequential for the most part to utilities until it reaches a certain concentration, at which point they say, you know, this is harming our business model, which is we sell power to customers. We don't buy power from customers at a retail level. So we can tolerate a little bit of that, but we don't want to tolerate a lot. So then they start pushing the utility or the legislatures to curtail or do away with it.
But it was introduced in the first place as a means of starting an industry,
Yeah.
Subsidizing them.
essentially subsidizing an industry until it got going well.
Yeah.
So it was not intended to be permanently at the full retail rate. Now in Ohio, it is not at the full retail rate, is my understanding. It's at the at a wholesale avoided cost rate.
It's not specified. It's basically utility by utility, how they've determined that. But my expectation is once a company, and I keep using Apple as an example, buys access to the grid, their business model will be, let's say Dave has a solar array and I don't know who your provider is. Let's say it's AEP or Duke or whatever. And they come back and say, we don't want to buy your net metered energy. We just don't want it. We've got enough. Well, Apple will go, yeah, we'll facilitate this transaction. We'll sell it to Bob. So they create a virtual marketplace where energy comes onto the grid and they create a customer. It doesn't matter where it is within the grid as long as it's interconnected within their system. And power goes onto the grid, power comes off, and then it's just a simple accounting thing. So Apple then becomes the largest utility in the country without owning any generating facilities or any infrastructure.
But Jay, isn't it more than I agree with where you're saying to go ultimately, but isn't it more than an accounting thing? Because there's real people out there who manage the grid who actually have to be able to handle this. And I think that I agree to where you ultimately are saying we're going, but I mean, there is some sympathy. These are regulated industries that we're all paying for. And if we don't find some way to efficiently transition from where we are to where we want to be, that's going to be a mess like the telecoms.
Yeah, and that's exactly the argument that was made in 1982 when Judge Green said, hey, you've got to open up this infrastructure. Now, the caveat was those people who want access have to pay a reasonable fee that will cover the costs of their use of that infrastructure. So now you start to, the devil's in the details. How do we make that happen and happen realistically? But it will happen. You know, if we're really going to deregulate the electrical market, it has to be more than just picking your generator. It has to also be picking your distribution device and your transmission device.
And compensating the guys who run that system to make sure that everybody, you know,
Yeah.
gets the power when they need it.
Although, you know, when you talk about fair compensation, these guys have been given right away over huge tracts of private property and public property without having to pay any of the costs associated with that infrastructure, other than the cost of building their own facility. So there is the counter argument that there's a lot of potential revenue stream that is simply being either diverted or.
Like I say, you can't pull. You can't. It's like the Mona Lisa. You can't pull up all those big old transmission towers and, you know, sell the land back to the people who are entitled to it anyway.
No, but you can share it. You can share that facility and still make a profit. And so what we're seeing is that a lot of the utility companies are well, all of them are basically stratifying their business. So they've got the transmission end, they've got the distribution end, and they've got the generation end. And because I don't know that they know where everything's going, but they do know that they've got to be able to respond to that. That's why I went on a tour of the coal power plants down in near Steubenville that AEP used to own, and they turned them over to Buckeye Power, which is the company that supplies power to the electrical co-ops. And it kind of cracked me up because the young woman who was giving us the tour, she was all giddy because she said, she was basically bragging that the co-ops did such a deal. They were able to get they owned one of the generating facilities, and there were 3 of them co-located, and AEP gave the utility or the co-ops the other 2 at no charge. And wasn't this a brilliant move on their part? And I was looking at it going, holy cow, AEP's probably danced a jig all the way from here to wherever their headquarters is, getting rid of these 1960s facilities with all of the, you know, millions and millions of dollars of decommissioning issues that are going to be involved in it. They just threw them over onto Buckeye Power's lap and walked away, because this thing looked like Soviet era technology. It was really a mess. I mean, there were literally, as we're walking through this power plant, most of it was taped off because there were all these leaks and things falling from the sky, and
they transfer the environmental liabilities too.
It's horrendous.
That's not for free.
No, but AEP, man, I would have given their CEO a huge bonus for giving those things away, because he avoided a big problem. And Buckeye Power doesn't see it. You know, they just don't see it. So.
But you know, if you talk to Bill Gates and Buffett, they're putting their money on cheaper, safe nuclear that's going to be using spent rods, and they're betting that that's going to outdistance solar and wind altogether in the final analysis.
I don't know. You know, maybe they're going to be right. Well, there's definitely an industry out there for getting rid of nuclear waste. To me, that would be the motivation, not necessarily the cheap generation of electricity, because nuclear is not cheap, regardless of how you slice it. But if you can take spent fuel that exists and turn that into real energy, that's goodness all the way around. But that's kind of a decommissioning thing as opposed to a renewable energy program per se.
But the other part is the way you do it will be safe. It's not going to explode in your face at the same time. No, just cost involved with it. They have a prototype going up right now as we speak.
And Jay, is nuclear not cheap because of actual operating cost or because of regulatory? I mean, I'm not, that's an open question. I'm not, I think,
My guess is it's always going to be a combination. Insurance costs are through the roof. They're only affordable if they're subsidized by the government, because the downside risk is so huge. You know, if there is a problem, the risks are catastrophic. So the insurance
You're paying a
companies
lot.
don't want to touch it. So then you say, but whenever you see a power plant that has been in construction, the costs always escalate way out of control. And whether that's because they've got to go through 75 inspection and delays there, or whether it's just inherent in the construction of their facilities, I don't know enough about it. You know,
It's
Well,
little
last
things.
time-
It's all the
What about
safety
Thorium?
engineering
Was-
that goes in. It's keeping them safe that is, you know, probably 90% of the cost.
okay.
probably.
And what about thorium? I mean, that you tell that they're doing that in India and that it's safer. I don't know that that's true or not, but I raised the question.
I remember reading some articles about that, and my general impression coming away from it is it's industry PR as opposed to anything, but that was just my overall impression. I'm anti-nuclear anyway, because the downside is just too catastrophic. And something always goes wrong. Doesn't matter, you know, over the course of centuries, something will go wrong. And so when we have better alternatives, why not take those better alternatives?
As they
You know,
used to say, it's the most expensive way to boil water that has ever been invented.
I always like but the other issue is currently our current situation is not sustainable. I mean, piling up spent nuclear material in the parking lots of power plants that are located near urban settings is a dumb thing to do. And if Harry Reid would have just let them stick it in Yucca Mountain, that would be better. It's still, I mean, I guess, is it better to concentrate all of this fissionable material in one place as
What
opposed
would you
to
say they should think of it in Philo?
Well, pretty much I can tell you the population would love it. They would say, good job, see, you know, they don't care that they're, you know, dying. They really don't care. We already have a toxic waste site in Philo that's not going to be cleaned up anytime soon. So,
Also, I see Edison out here is getting more interested in not buying electricity, but in distribution.
yeah,
And I really believe that they're going to charge the same amount of money for the distribution without the energy than they're doing right now with the energy. And
Yeah.
they're mandated to get off of that pathway anyway. So as long as they can make their money one way, they're going to do it.
well, if you look at the numbers that we talked about at the beginning here, where residential customers $2.71, commercials $1.72, and utility $94. Basically, the difference between commercial and utility is less than twice, yet retail versus wholesale is more than twice. So your customer base can create their own generating facility cheaper than you can afford to build it and sell it to them. Well, what kind of long-term market is that? Where your customers can always underprice you by building their own. The barriers to entry on electrical generation today have disappeared. So if I were a utility company, generation is not the place to be, because
Jay,
you're going to lose.
Is that pricing including storage? And I ask that because if you don't include storage, then you're not really able to get rid of your power company.
Right. Well, that's true. And these prices are just, you know, basic bare bones grid tie.
Yeah.
But energy plus storage is coming down dramatically. And at the residential level, I would say within a decade for sure, and maybe much quicker, we're going to see grid parity with production and storage. to be comparable to that of buying your power from the utility company. So basically the same situation we saw with production in 2012, where you now had a 25-year payback on a 25-year system. We're going to see a 25-year payback on a 25-year system pretty quick with production and storage. Now, if you integrate your EV, that's going to happen a lot quicker because that's already a sunk cost that you don't really have to account for in your storage budget per se. So we may see it within 5 years, you know, who knows? Or we may see it already today. So,
Do the wires eventually disappear? Do we lose the wired networks, or what happens? Do we have both? If we do have half the people generating their own power, who pays for that wired network?
yeah. It just reminded me when you said that, because I remember back in the days of telecom, and they'd always say the wireless office will come about at the same time we have a paperless toilet. You know, I mean, it was like, there are certain fundamental advantages to things being wired together. Usually it's less wire as opposed to wireless. And it's usually that final point of connection that is the advantage for mobility. You know, so I don't see us having a wireless electric grid, especially if you think about the intense electromagnetic fields that would have to be generated for the high transmission lines and things like that. You create some dangerous situations. But maybe the final connection point between your appliance and the wall may at some point become wireless if the voltages are low enough and the technology advance enough, you know. But I don't see us, because wire is just a better transmission medium than air, you know. It just is.
I would hate to see the electric bill the last guy hooked up to the grid is going to get.
Who knows? You know, it'll be interesting. It's interesting and changing, but I do expect there to be quite a pushback from government, as I think I forget, was it Ben, I think, had mentioned before about the pushback on net metering. We'll probably see that coming in a number of fronts. But my argument with government has always been government can advance the technology by a year or two or retard it by a year or two through their policies, but it will slowly march forward regardless of who's in charge, you know. So I think that's where we'll go. All right, anybody else have any closing thoughts before we call it a day? Okay. Bill, are you wanting something or are you saying goodbye?
Yeah, I just wanted to ask a simple question. Several weeks ago, I brought up I think it's a 5 kW ground mount that's 90 foot from the service. And I asked the question about either running DC to 90 feet or AC 90 feet. And in terms of wire sizing for voltage drop, there's no inherent advantage of one or the other. You still got to do the sizing for the amps and the power.
Yeah, my understanding is voltage drop is not dependent upon whether it's AC or DC. It's mostly dependent on the level of voltage present within the wire. So the higher the voltage, the less the impact of voltage drop will be, you know, on the wire size.
Okay.
The main three issues,
that.
yeah, it's usually distance, wire size, and voltage. You know, those are the things you look at when you're worrying about voltage drop.
Okay.
Okay. But 90
Thank
feet
you.
shouldn't be a big issue anyway, because the voltage drop will be reasonable if you've got wire big enough to handle the amps.
Well, you just ohms per 1,000 foot for wire and do the round trip distance, and you get some ohms, and the voltage drop. I'm saying 1%. You know, size the wire for 1% voltage drop.
Yeah, usually
yeah, okay.
2% is sort of acceptable. Yeah.
Yeah.
But I found
Okay.
unless your distances are more than 200 feet, if you've got wire big enough to handle the amps, then you're going to be within the 2% voltage drop. So,
Okay. I actually have another question. People find me for helping with broken systems, and somebody found me. They had a Reliant lithium battery. These are $8,000 batteries in a trailer, in a 40-foot container, and it was 48-volt system, and the measured output was 2 volts. We opened a battery pack, took the lid off. It was a question of prying the lid off because it had a rubber seal, and actually found 45 volts within the box. So there is a relay apparently, I suppose, or whether it's solid state or whatever, that's preventing the voltage from getting out. This is Reliant brand, and it was sold by Iron Edison. And we're having trouble getting, speaking to a real person in technical support. Anybody in this call that has had any experience with Reliant or Iron Edison?
are you sure it's a lithium ion? Because Edison
Absolutely.
batteries.
I can see a massive series parallel of 1865 size batteries.
Yeah, but it
And
could be an iron. What do they call that? Iron. The Edison batteries are iron based as opposed to lithium based.
No, I can see some lithium cells. I assume
Okay.
they're lithium cells.
You might double check.
I
that.
wasn't there. Yeah, huh? Double check that.
Yeah, because it could be.
Are you suggesting the nickel iron chemistry is a possibility in the form factor of the 18650 cells?
I'm not familiar with those cell structures. I just know that, yeah, the nickel iron are usually marketed by, they're referred to as Edison batteries. So that's what kicked in my mind when you said that name. The
Okay.
iron Edison would tell me they're like a nickel iron battery.
Right.
But
No,
it
but
could just
they
be.
also have a lithium battery for sale on their website also.
Oh, okay.
So
All right.
yeah.
Okay.
Okay. Thanks.
Sure thing. Take care, everybody.
Yeah.
Bye-bye.
All right.